Hi, my name is Nick Borson. I'm a software engineer at Microsoft, and today I want to explain the meaning and use of the static keyword in C Sharp, because I think that's a keyword that people see but don't always fully understand what it means. So the basic idea is shown on this slide. So here we have a class called myClass that has two data members. We have an ID, which is an integer, and a last ID, which is also an integer. So they're both integers. The only difference is that last ID is static. So what does that mean? It means each instance of my class, each object of type my class, has its own ID value. But there is only one last ID value. It is static, which means that there's only one. It belongs to the class as a whole, not to each individual object of that class. And furthermore, when we want to refer to the ID member of this class, when we want to refer to the ID field, we do so using a reference to the particular object that that ID belongs to. But when we want to refer to the last ID field, we do so using a reference to the type that it belongs to, because it doesn't belong to a particular object. It belongs to every object of that type. It's one shared field that belongs to every object of that type. Static can also apply to methods, and I'm going to show you a couple of examples where we'll use both methods, fields and methods. So here I have a Visual Studio 22. I've just started it, and I want to create a new project. So I click Create New Project. I select a project template. I'm going to use the C# console app template. So I filtered the list of templates by selecting C# as the language and console as the project type. So that's the template I'm going to use. I click Next. I'm going to call my project Static Demo and click Next, accept the defaults, and create the project. So Visual Studio is going to create a new project for me. The project name is Static Demo, or excuse me, the solution name is Static Demo. The solution contains one project, also called Static Demo, and it has initially one source file called program.cs, which just has your traditional hello world output. I'm going to delete that. And let's create a new class. Now, the convention in C# is typically to have each class in its own source file. So the easiest way to do that here is I can right-click on the project name, choose Add Class, and I'll type in the name of the class. I'll just call this My Class, and click Add. And it's created a new source file, which we see in the list of source files for this project. And it's added some using statements, a namespace with the same name as my project, and then the class is a member of that namespace. Namespaces are just a way of grouping things. It's just an organizational thing. So classes can be grouped into namespaces. I don't need all these using statements in this case, so I'm just going to delete them. And just as I had on the slide, I'm going to add two integer fields. One of them is going to be, I'll make them both public. One's going to be called ID, and one's going to be called last ID. And the only difference between them is I'm going to make last ID static. Okay, so let's see how that works in practice here. So we go into program.cs, and I'll say using my static demo namespace, and I'll say var1 equals new my class, and var2 equals new my class. Okay, so if we want to refer to the ID member, then we need to refer to the particular object, particular instance that ID belongs to. So we can say 1.id equals 1 and 2.id equals 2. But if we want to refer to the static member, which is called last ID, we need to refer to the class instead of the instance, because the static member doesn't belong to a particular instance. So if I try to say 1.lastid equals 1, it's going to give me an error. It says member myClass.lastid cannot be accessed with an instance reference qualified with a type name instead. So I have to do it exactly what it tells me. I have to use the type name myClass.lastid, because again, it's a static member, it belongs to the class, not to a particular object. So it should be obvious now that, if I say my class dot, let's say, yeah, so both objects are going to have the same class ID no matter what I do. I can't say my class dot last ID equals 1 and my class last ID equals 2. I'm just going to be setting the same value twice. I'm not going to be storing a different value for each object. Last ID is shared across all instances of that class. Okay, no need to really compile or run this program. Let's just let's try another. Let's see how we might use this in practice. So, why would we want to make something static? Well, here I'm going to change this one to private, and I'll rename it to m_last ID. And let's say that I want each instance of my class to be automatically assigned a unique ID. So I can use my static last ID member as a way of keeping track of what was the last ID I assigned to any instance of this class. So I initialize it to 0 because we haven't created any objects yet. And then each time we create an object, we'll assign it a different ID. So to do so, we'll create a constructor. Constructor doesn't have a return value, but it has the same name as the class. This constructor has no parameters. And we're going to we're going to increment last ID. Remember, I can qualify this name if I want. I don't have to, because we're in the class. It knows I'm referring to this member of the class. But it might be clear just to say my class last ID. So we're incrementing this value, this static value that's shared by all objects of this class, and we're going to store that in the ID member. And instead of making this a public field, I'm going to make it a read-only property. So now the ID is initialized in the constructor. It can only be assigned to in the constructor because it doesn't have a setter, and it can be accessed anytime by anybody because it has a public getter. Okay, so that's my class. Now if I say var1 and var2, then when I run this, I should see that line1.id console.write line2.id. When I run this, I should get 1 and 2. And just to see how that works a little more clearly, we can step into this real quick. I'll hit F10 to single step through the program. I'll hit F11 to step into my constructor. And we can see that last ID is initially 0, but we increment it, store it in the ID property, and now this has an ID of 1. And then when we do the same thing here, step into it, last ID, again, the static member, it's the same last ID that we were using last time. It doesn't belong to a particular object. It belongs to the class as a whole. So it's still 1. We now increment that, store it in the ID property, and now this object has an ID of 2. So again, the ID, the instance member is per object, but the static member is per class. Okay, so that basically summarizes how static and instance members work. But let me show you one more example that could demonstrate a static method as well as a static field. So let's get rid of what we have here. I'll get rid of my class. Instead, let's add another class. We'll call this item. So add class, call this item, and let's say that this represents an item in an inventory. It's like a grocery store's inventory, for example. So it's going to have 2 properties. One is a name, which we'll call, which will make a read-only property, so we can only set it in the constructor, and we'll have a count, which will make a read-write property, so that's a getter and a setter. So we can modify the count, but we only want the name to be initialized once when the thing is created. Now, the key thing here, the reason that I'm going to use a static member is, let's say that I want to get the count of apples or something. Well, I get an apple object, and I increment its count or I decrement its count because I've sold an apple, say. Now, if we sell another apple, we want to get an apple object and decrement its count. We want to make sure that that's the same object we had last time. So one way we can do that is we can have a dictionary, which is a kind of collection that is where items can be selected based on some property called a key. It's like a database kind of. So we can have a dictionary of items with the name as the key for that dictionary. So in order to make this work, we don't want to have a dictionary for each. We don't want each item to have its own dictionary. We want one dictionary for all of the items. So we'll make that static, and we'll make it private because we'll make the interactions with this dictionary all part of the class definition. So we'll have a private static dictionary. If I can spell dictionary, we'll use the type of the key is string because that's the name, the type of the name, and the type of the value is item because that's what we're storing in the dictionary. And we'll call this m items, and we'll initialize it by as a new dictionary. Okay. So this is so this is a static member, so it belongs to the class as a whole. There's only one of these dictionaries, and then we want to have some way of being able to get items from that dictionary or add them to the dictionary if they're new. So how do we do that? Well, we can have a method, a static method. So let's make a public static method. The method will return an item, and it will be called get. It's just get. And parameter of this will be the name of the item we want to get. And what this will do is it will either find the existing item in the dictionary or it will add an item to the dictionary. So there is an m. The dictionary has a method called try_get_value. So we'll call m items.try_get_value, pass in the name. And then the first parameter is the key, the thing we're looking, the name we're looking for. And the second parameter is an output parameter that receives a reference to the thing we're getting from the dictionary. So in this case, it's going to be, we'll call it out item. This has to be the name of a variable, so we have to define the variable up above. So we'll call this item. Okay. So this is the type, and this is the variable that we're going to fill in. Now notice here we have a warning or an error converting a null, literal, or possible null value to a non-null type, unnecessary assignment of values. So it doesn't like that this is not nullable. So by default, a variable has to refer to some object. If we want a variable that can be null, meaning it doesn't refer to any object, we have to qualify the type with a question mark. Okay, so now item is initially null. When we call try_get_value, one of two things will happen. It will find an existing item in the dictionary and store a reference to it in the item variable, or it won't find the thing and item will still be null. And the way we tell which is from the return value. If it got the item, the return value is true. If we hover over this, it'll tell us all about this. If it doesn't get the item, the return value is false. So we need to handle the false case. If it doesn't get the item, if not, try_get_value. In that case, we don't already have an item, so we have to create one. So we'll say item equals new item. And here is where we need to initialize the name for the item. For that, we need a constructor, but let's go ahead and add that. Private item string name. So this dot name equals name. And just to be clear, I'm going to say item.mItems. So this is a static member. Again, here the this dot is not needed, and here the item dot is not needed. But since I'm the whole point of this video is to distinguish between the static members and the instance members, I'm going to include these qualifiers here. So we're going to create a new item. We specify the name of the item, and then we add it to the collection. Item.mItems.add name item. And when we're all done, by this point, we have our item. Either we found it in the dictionary or we created it and added it to the dictionary. Okay, and again, the constructor, we have a constructor here because it's needed here. This is where we knew the item. And part of the reason we need a constructor is because the name property is read-only, so it can only be set in a constructor. Okay, so how do we use this class? So here we have a static dictionary, a static field, and we have a static method that refers to that field. And this is allowed because a static method can refer to other static methods. I couldn't here, for example, say count equals, I can't say, this dot count. It won't even let me autocomplete that. But I can't refer to the count member in this class because it's not static. I don't have an instance. I don't have an object reference to refer to that count. But I can refer to the items member because it belongs to the class as a whole. It's static. Okay, so let's see how this works in practice. We can say apple equals item dot get apple. Okay, and then we can say console.writeLine. Well, let's just set the count. Say apple count equals 100. We have 100 apples to start with. And then let's say var turkey equals item.get turkey. And we'll say turkey.count equals 50. And then we'll say item.get apple count minus equals 5. All right, what does this just mean? We initially got an inventory of 100 apples, so we stored that. We get the apples object from we use our get method, our static get method, which is, because it's static, the thing to the left of the dot has to be the type name. Okay, so we use our get method to get the apple object from our dictionary. So this variable now refers to that object. And we set its count to 100. Here we use our get method to get the turkey object from the dictionary. In both cases, these are creating a new object because we didn't already have any. But we get our turkey object, and we set our turkey's count to 50. Here now we get the apple object again. We're not using the apple variable. We have the name. We get the object from the name. But this is going to return the same object that we have up here. And we, here we have an instance member. To the left of the dot doesn't have to be a variable. It can be any expression that returns an object. So here we're taking the object returned by the get method, and we're accessing its count member, and we're decrementing or subtracting 5 from it. And we're using the minus equals operator to subtract 5 from it and store the result. So here the apples count is initially 100. Here we're subtracting 5, so the apples count should be 5. So now let's see what we have. We can say console.writeLine item.get apple count. And we'll do the same thing for the turkey. And what we should see here is the apple object count should be 95 because we set it to 100 and we subtracted 5. And the turkey object count should be 50 because we set it to 50 here and we didn't change it since. So let's go ahead and run this program. And indeed we see 95 and 50. And just to kind of be clear what's going on, let's go ahead and step into it. So I'm hitting F10 to start debugging, single stepping. And I'm going to step into the get method. So item.get is how I refer to the static get method of the item class. I passed in the name apple. So I try to get the key apple out of the items dictionary, which is the class-wide static dictionary that we've defined. And it doesn't find it, so the method returns false. So therefore we create a new item. And we've invoked this constructor that's set the item's name property. And then we add that to the dictionary. And here we are with our item that we just added. We return that as the return value of the class. Store that in the apple variable. We set its count to 100. Now we do the same thing with turkey. Again, we don't find a turkey in the dictionary, so we create a new object with that as its name, store it in the dictionary, and return this new object, which is now stored in the turkey variable. We set its count to 50. Now again, here we're invoking item.get with Apple, so let's step into that. We again look up the name Apple in the dictionary. This time we find it, so we just return the existing object. So we still only have one Apple object. And now we're accessing that object's count member. We see that the count here, if we hover over that, well, here's the object here. This expression returned this object. Its count is 100. And then when we step over it, its count is 95. But we have, we can't see that in the debugger because we're past that statement. Now let's step into this one more time. Item.get Apple. Again, we find the value already there. And by the way, if we look at this dictionary, mItems, we can see that it has two members because we've added those two items. Anyway, we return that existing thing. We read its count, which is, of course, 95, and we write the turkey's count the same way, which, of course, is 50. So, to review, an instance member belongs to a particular object, a particular instance of class, or instance of a type, whereas a static member belongs to the type itself. So in our example, we have fields where the data members, the fields, are either in this example, we have a name, which is well, the name property. It's not a field, it's property, but the name property belongs separately to each object. Each object has its own name, and each object has its own count, but there's only one items dictionary that is shared across all instances of this class. It belongs to the class itself. And when we refer to it, we refer to it not using an instance, but using the class itself. So that's the difference. And of course, we can have a static method. The same thing applies to properties and methods as applies to fields. You can have a static method that you call on the class. We say item.get. We don't say apple.get. And the usefulness of this is if you want to have values that are shared across all instances of a class, that's what static is for. Okay, I hope this was instructive for you and that you enjoyed the video, and thank you for watching.